Okay, so Newton's law of cooling, the class just said, this is an exponential function. Like if I said this is y equals, this would be our a, this would be like our b, and that would be like our x. Now, what would this part that's added to that be? That would be like our k, our shift, our vertical shift. Isn't that what that does? If we add or subtract something to a function, that's our vertical shift. Now, in terms of Newton's law of cooling, this T sub E, what is that? T sub E is the temperature of the environment. Now, let's tie all this together. Now, the Willoughby is a coffee drinker. She likes her coffee with no sugar.
Really?
And I do not do sugar, but I do pour enough half and half in it to support a good number of dairy bars. Okay? So it never looks like coffee. It's a pretty different color.
So 1-to-1 ratio.
It's pretty close 1-to-1. I mean,
So it really is
I
half
have
and
strong bones though, just for my half and half.
Yeah.
All right, so I love my coffee. I give myself a cup every day at school. Usually decaf when I get to school because I have so much energy. Y'all don't want me having
I do.
more caffeine. Okay, so here's my coffee, and I take some sips during the day. But eventually, my coffee, even in this great little, what do you call these things?
Yeah.
Yeti,
The
even
best
this
things
great
to-
Yeti, eventually it cools down. What is the lowest? Okay, what temperature do you think? Yeah, coffee. Yeah, see what color it is? It's almost white.
Really?
Oh yeah. Oh yeah. I know. I wasn't lying. I like a lot of half and half. It's the real stuff too. I don't use that fake stuff. I'm talking real creams right here.
Yeah.
Okay?
I was waiting for it
Yeah.
to cool down.
Okay, so what temperature is this coffee that I poured this morning now? It's room temperature. Will this coffee ever drop below room temperature?
No.
Maybe put it in a fridge. Asymptote.
Because the room temperature acts like the asymptote. Except, the weird part is, with asymptote, we never quite get there. This coffee's there. It hits the room temperature and stops. So it's similar to an asymptote, but the temperature of this coffee hits there. And that might be important when you're trying to figure out who done it tomorrow in your murder mystery.
Hunter.
Okay, so, now the other thing, because these equations are the same form, it's basically two different ways to write the same thing, isn't it?
Yes.
And so interesting things will happen tomorrow when you look at your murder mystery in both ways. What if I looked at it in this way with base E? What if I looked at it in this way with a different base? But it's the same situation. So when you graph it tomorrow, you're going to have this little aha moment. Ah, yeah. Might be Hunter. We don't know.
What was me?
Okay.
I'm the detective.
All right.
You read the part.
I'm the
So let's dissect it, each little part of this equation. T of T, that is the temperature of an object or substance with respect to time. What is the temperature after a given amount of time? That's what T of T is. T of E is the temperature of the environment, which changes. The environment can change. T naught is the initial temperature of the object. Okay? T is time and K is our constant. And that is generally what we have to solve for first, that K. We have to find the cooling constant. All right. So, our first example is of a hard-boiled egg. And this hard-boiled egg is at a temperature of 96 degrees Celsius. That is probably because it just came out of a boiling pot of water. What is boiling temperature for Celsius? 100 degrees. Okay. All right, now this egg is then placed into a bowl of 16-degree water to cool. 4 minutes later, the temperature of the egg is 45 degrees Celsius. When will the egg reach 20 degrees Celsius? All right, so let's identify what we have here. 96 degrees Celsius, is it any of these?
Yes.
What is it?
Initial temperature.
It is the initial temperature. That's our T naught. Thank you very much. 16 degrees Celsius. Which one is that? Temperature of the environment. That's the environment in which we placed our egg. That's TE. All right, 4 minutes later, the temperature is 45. This 45 is a temperature that we were given with respect to a time, wasn't it? So this is my temperature with respect to a time, and there's the time, guys. It is 4 minutes. All right, so if we look at this, we have T naught, TE, T, and T of T. The only thing we don't have is K, which is fabulous, because that's what we want to do first every time, find K.
Okay, so.
All right, so let's plug it in and find K. So 45 equals 16 plus 96 minus 16 e to the negative k t, which is 4. And then we have to get it in the right form. So we're going to subtract 16, which is 29. 96 minus 16 is 80. What do we do next, guys?
Logarithm, we subtract 4K.
We are going to do ln, but what do we have to move?
4K.
80.
80?
So we have to divide by the 80.
First, close though.
Yeah,
You do that first.
we do need to do that first. So that now we have just this base raised to an exponent. Now we would take the natural log.
Yeah, okay. I got it.
Yep, I got it.
Okay, so ln of 29/80 equals negative 4k. Divide by negative 4, and we're all done, aren't we?
Technically, no.
Okay, now if I ask you for k, at this point you could probably plug this in and give me a nice decimal. But that's not what I asked you for. We need this value to answer the question. So, if I have to do more work, do I round? No. I use the exact value so that I do not compound my error. All right, so now we got to use this k. And k is what we'll be solving for first in many of these problems. Not all of them, but many of them. So now we found k, and now we can answer this. When will, so we don't know what t is, when will the egg reach 20? So the temperature with respect to time that we're trying to figure out is 20, and time is now what we don't know. The initial temperature didn't change, the environment didn't change. Okay, so plug it in and see if you can solve.
Come on, baby. Come on. I'm so hungry. You know what I eat when I get home? Burger shop.
Have some fresh fruit.
I'm gonna eat some strawberries,
Ooh, good
2
choice.
bologna sandwiches, mustard,
Okay.
and probably some tea. Really right now. And maybe some.
Started off healthy.
And then just got.
I have practice today, so I need to fill up before I go.
You literally
Think
come
you
to my
get
house
cramps
and
later?
eat. That's all you do.
So what do you want to surround it to?
True.
Let's do the nearest 100.
I am starving. I eat
Because when I
2
come home,
days. You're like 2 boxes of one wafer.
Okay. I would make fun of him, but that's like every teenage boy.
No, he goes, dude, I'm so hungry. I haven't eaten like 2 days. He goes and just eats anything he sees.
I ate
He ate like
sour
half a
bread.
loaf of bread. Just like sandwich making bread. Just like whole wheat bread.
You made bread
His
sandwiches?
mom bought some really good bread, and I thought it was really good until I ate it. And I was like, what is this bread? And Hunter was like, did you eat it? And I was like, no. He was like, sourdough. I was like, that's why it tastes sour. I was like, I said,
You
you
just,
just
he goes to my house and just eats anything he
No,
sees.
I come to his house after practice, and then I'm hungry because I'm broke.
She don't like some food.
She So you got the first part? Go buy some food.
Don't you have a job?
Yeah, I'll get paid this Friday.
And then that's not
Then you're
enough
gonna
money
quit.
to eat
It goes to the ticket. Doesn't even go to me.
Wait, Julian, where do you work?
Wendy's.
Then you're gonna quit after this
Seriously?
Friday.
Oh, right, after this Friday, I'm gone. I'm just not gonna show up for hours. She's like, where's Julian at? Call my mom. Mom, I'm not answering.
You quit?
I'm gonna work at that. You're retired.
Oh, you wanna work
Don't you
at
know?
Okay,
But this is
real quick, let me give you some words of wisdom. If you're hoping to get a different job, then you would never leave your last job in a bad way. So you wouldn't just not show up.
That looks bad.
That would be
You gotta put
bad.
in your 2 week notice, Julie.
You would be very.
What? I could put
Not
2
kidding.
weeks in before I quit.
Like, not kidding. You gotta put in your 2 weeks notice.
That means I gotta put it in today.
No one.
I want to work in the fish store.
Bless you. Wow, the numbers just like.
Bless
have- Whoa, that is so. How did you do it?
The movie you can move your objects around.
Wish we could do that with regular math.
Alright, so guys, when you get to this point, you can either divide by this or multiply by the reciprocal. I don't know how calculator savvy you are. It's harder to mess it up when you multiply by the reciprocal. You've got some extra need for some extra parentheses if you divide, which is totally fine. You just have to be calculator savvy. Alright, and so you should have gotten approximately 11.81 minutes later.
What? Oh. Oh, I did that one. Wait.
Alright.
So I guess plug in K too, right?
Yep.
Oh, yeah, I didn't do that part.
We gotta know.
I just because you asked, your mom asked me.
Like a guy that eats dry pasta.
Who?
There's like a handful of dry macaroni and just start eating it.
Alright. By the way, I am recording.
Well then, people will enjoy that conversation.
They will. They will.
You're like, those kids are interesting. I want to go to that class.
Alright. So, number 2 is the same concept, but something different is missing. So this time, an aluminum beam was brought in from the outside to a machine shop where the temperature was held at 65 degrees Fahrenheit. After 10 minutes, the beam had warmed to 35 degrees Fahrenheit, and after another 10 minutes, its temperature was 50 degrees Fahrenheit. Use Newton's law of cooling to estimate the beam's initial temperature. So, I know all of you are saying, well, if we brought it in from the outside, the beam was whatever the outdoor temperature is. So all we do is open up our app and it tells us. Okay, we don't have an app. So, we're going to have to use a little Newton's law of cooling. How do we do it?
We have to put in all these things.
We do have to plug in all these things.
And then
Now-
we find the initial. They give us a T on it.
The problem is, we don't know T naught. That's what we're trying to solve for. But we do have a first temperature and a second temperature. And so what we have to do in this case, even though 35 is not the initial temperature, it is the first reading we were given. So we have to assign 35 as T naught's temperature. So we have to, T naught is 35 degrees.
You call it not, 0 is not?
Yes. Like nothing. Naught.
Oh.
Okay? What is TE?
TE is
65.
65.
And 50
All right.
is TT.
And 50 is T of T.
I was gonna put 35, not gonna lie, for that
Okay?
first time. That was like a good.
Because we do have a time with 35 too. Yeah. But what is the time that is with 50?
20.
No, but in respect to 35.
In respect to 35, it's 10. Good. Good catch.
You're
So,
smart. Don't even think like more.
she is. All right, plug all these things in here and see if you can solve for K.
Reverse psychology.
So far, this is exciting because this is the first class I haven't caught somebody watching basketball in.
Oh, really?
My bracket's busted.
I got caught last year.
I got caught in this spread.
My bracket's already busted.
Did he actually?
Good thing I had 2 more. Wait,
Yeah,
3 more.
my bracket's already still good.
I have one that's 100%.
I'm right.
I have one that's 100%. It says I'm ranked first out of everything. So if that's it, I hope that's probably not. It's my Villanova run. I think those probably the least ranked
They're
team.
not gonna win. There's no way.
What makes you
It's just alright.
I got
You're going
It's
to.
.026.
Okay, well,
Who thinks wins? Who you wins?
I put Duke, but
You.
Why do?
He just put Duke, just to put it.
pretty much.
The closest competitor to win is UCLA.
Yeah,
I
I
put
think
Duke versus
UCLA.
UCLA.
Yeah.
UCLA's not winning because I feel like he's gonna bust.
Wait,
Kentucky's not gonna.
you guys started.
Like, yeah, no one. I think Duke versus UCLA.
UCLA already beat
We had like the joint.
I think UCLA.
Yeah, and how many times did I beat UCLA?
What? They're both even. They're in a tournament.
I don't think so. Yes. I don't think so. Nobody had a game.
Yeah, we're always like.
The colors are.
From the school, from the art, or.
Yeah.
No.
Whenever they pull up.
All right.
Hey, can you plug this
Did
in?
you get K right?
Wait
Yes.
Wait,
If you
no.
plug it in, I would.
So then
Let's set it up right.
Plug it in.
Okay.
Wait, what?
Now there's 2 options, guys.
Where did you get -5 from?
Oh, yeah, I got this.
0.5. Because negative 15 divided by negative 30 is 1/2. 0.5.
Okay.
Okay.
I'm so glad I got this way. Alright. 0.5. Why you saying that? You got something?
No, I did.
I got a 1 out of 10.
I know I did.
Okay. So now we have 2 choices.
Okay, can you calm down?
TFT can now be 35 and T10, or TFT could be 50 and T would be what? 20.
I like that.
Oh, good. So, gentlemen, you work the problem the second way. Ladies, you work it the first way. And let's,
Plug into T for 20.
yeah,
20.
gentlemen, ladies.
So wait.
So,
plug it- wait,
you
we
put
plug it
20
into,
in.
I see. I don't have a calculator
What do we
though.
plug it
Okay,
into?
L.5.
Plug it into the
basically,
class,
I just
right?
did this
Or am
up.
I wrong?
You plug it into this.
I
Oh,
already
okay.
did set it up.
So now we have K,
Oh,
we have TFT, we have T, and T of E didn't change. So we're solving for T naught. We can now solve for T naught. The initial temperature.
Do I fill the negative sign in front of like LN 0.5 or something?
Well, the negative and the negative are going to cancel.
So it just
So, yeah, on both of them.
Hokey hokey. Never again.
It's funny. Why you somewhere? You know what's wrong with you? That's wrong. You made this way.
Okay, let's work.
No, I am. I plugged in. I'm plugging all this shit up for you.
What up, John? Turkey?
Oh, this is awesome because it uses our properties. Let's see what they remember.
Oh wait, I'm a
I thought it was
Where'd you get -35? I'm -30 from. What do you mean -35?
Wait, did I do it wrong?
35 minus 65.
-100.
Hunter?
Yeah, what'd you get?
Oh! I said -30. I'm stupid.
Okay, here we go. I got it.
Okay.
No, didn't do this right. Okay, I give up. Okay. So
Don't you did?
I got that right. That's right. And then the second line, I'm just like,
You need a calculator. So I can have that.
I see what you did there.
All right. If you're not good with your properties, then just punch this into your calculator.
Okay.
Punch. Woo, that was fun. Punch this into your calculator if you're not good with your properties,
-0.0.
including the E.
Before the quiz this movie, I was watching one of the videos.
Oh, it's
I
times
can't even hear us.
Something went wrong.
I heard like our voices, but we can't understand what we're saying.
because we don't understand half the stuff we're saying.
You can't
I couldn't make out the
We
words.
sound like a bunch of gibberish.
The British dog.
So I got negative 13 minutes.
I don't think you did right.
I don't think I'm breathing.
Tired to do it.
I'm not gonna choke.
Remember, we're at a different.
What can get you?
Okay, I just used the properties, guys. And I said, okay, the 10s are going to cancel. And e to the ln of 0.5 is just 0.5. Okay, here I use the properties too, but I'm just not done. You'll see it in a second. ln of 0.5 times 2 is the same as 2 times ln of 0.5, which is the same as ln of 0.5 squared, which is the same as ln of 0.25, so that's where I got the 0.25.
If we would have
I did a lot of that in my head.
question on the quiz, we would have gotten it.
This is the.
I said just punch in a new calculator.
It's
They
not.
gave me this really crazy number, like an 8.
No, I got negative 13.8.
Negative?
You punch just this part into your calculator?
That's why I got.
I mean, it
Just
probably
what I
is.
have in the box. Oh, so divide by 10. All ln of 0.5 closed over, so divide by 10 times 2.
Yeah, I got that.
Alright, so you should have noticed that, gentlemen and ladies, you see that right here, your line of work matches? And so either way we do it, and we knew this was going to happen, because we didn't change anything in the problem. We should get the same thing.
It was hard.
This is more challenging, yeah.
Remembering the rules are
Yeah,
hard.
it's kind of challenging. It's just so much memorizing. And I'm like really bad memory.
Really?
Yeah.
Remember that time you begged me in third period?
It's like, that was so bad. That was today.
Alright,
It was like,
Oh my goodness.
you just said I look like
He's singing from the water.
Yes.
Shiny?
Yes.
That's my song.
what?
alright, number 3. New substance. So we've done an egg, we did a bean, now we're going to do some soup. Alright, so suppose that a cup of soup is cooled from 90 degrees Celsius to 60 degrees Celsius in 10 minutes in a room whose temperature is 20 degrees Celsius. Use Newton's law of cooling to answer the following questions. How much longer would it take the soup to cool to 35 degrees Celsius? Alright, so first of all, we have to determine the cooling constant.
20. Nope. I'm stupid.
Oh wait, the T not?
We have to find K.
Oh.
I was like, when she said constant, I should have
Just
clicked.
slip by.
So we have to find K. Crackers.
And I'm going to give you like a check step. This is what K should be.
Wait.
4 to the 7. Wow. Over 2. Maybe 10.
Alright, so see if you can do it, and if you need some help, please ask. I'd love to help you.
What would you put in T? Oh. No? Yes. So you just found around 7, found like 40, you just found factor of 10.
Yeah, so when I did 40 over 70, I just canceled the zeros and made it 4/7.
You can do that.
Yeah.
Can you do that too?
Oh, I was doing the wrong one.
Oh, I just focus is great.
I was doing the wrong one.
Oh wait, yeah, I did do it right. Shut up.
Okay, so we're actually not there yet, guys. All we did was find K. And this says how much longer would it take it to get to 35. So we did part 1 of this question. We found our cooling constant, which is necessary to discover how much longer.
You find, yeah, you found a new one.
I would have been
That sucks.
Okay, so how much longer means, there's 2 ways we can do that. We can say the initial is still 90, or since we're trying to find how much longer from right now, we could do 65, right? Wait. Not 65, 60. If we did 90, we'd have to subtract the 10 that's already happened.
From our time that we did at the end of it. Okay, so that's like an easy to explain.
Yeah. So if you did 90, it's not a biggie. K is this, and the negatives are going to cancel pretty much every time. And so we get 15 equals 70e to the ln of 4/7 divided by 10 times t. So divide by 70, and so 5 goes into both of these, right? Yeah. And then we take the natural log, and so that brings this down. And you can multiply by the reciprocal. I got 27.527. But then we have to subtract out because it just wants to know how much longer. And so since 10 minutes have already happened, it would take 17.527 more minutes. Okay, now, in part B, it's like we're on one of those cooking shows. Have you ever watched, like Cupcake Wars? And sometimes the cupcakes are too hot to ice, so they have to run them over to the blast freezer and cool them off for a second so the icing won't melt off of them.
I should love that. That's my favorite part.
The next time they have a marathon, you should
Looks like peanut
find
butter
a
on
friend
hot
and go.
dogs.
I would say-
Julian, let's go.
There you go. Yes, sir.
For that
Let's watch
problem,
some bacon.
I got
I got like all
Let's
those
watch
right.
some Aces Scratch.
But I got
You get
point 27527. Well, I'm wondering like where I dropped the decimal place.
You probably forgot to, when you did the reciprocal here, you probably forgot to multiply by 10. Because multiplying by 10 will shift that decimal to where it needs to be. Yeah. Okay, so even though we're using a different environment, we're going to stick with the same cooling constant because it's the same substance. We can have some academic debate about whether or not we think this is a valid choice. But instead, we're just going to work the problem. So, K is natural log of 4/7 over -10. So we're going to use the same cooling constant for the same substance. What we've changed is the temperature of the environment, right?
Yeah.
So now we have it in this blast freezer at -15 degrees Celsius. That's pretty chilly. Yeah. Okay, so let's see if you can figure out how long it'll take.
Alright. I can do it.
Miss Rosie, where'd that 10 come from at the end of the last one? The -10.
Because 10 minutes had already passed, it says how much longer. You would subtract away the 10 minutes that are already passed, so there's only 17 and a half minutes left.
Alright, got it.
Wait, so we have to find T, right?
On this one,
Yeah.
yes, we're finding T.
Okay.
Ow. What? I stabbed myself. You don't know how much it will. Negative.